here. Okay, cool. Sorry. So you could, one thing you could do is divide by 3y. You can see that? And there's two reasons, the two main things you can do are the same. Where is my m? I'm trying to solve for m. Where is it? It's in here. It's stuck in there. There's two ways to make it unstuck. One way is divide this stupid thing away. Then it's not stuck anymore. If I divide the 3y away, do I need parentheses anymore? The only reason those parentheses are there is because the 3y is there, right? The other way to get rid of the parentheses is more direct. What can I do with the 3y? Distribute it. Okay. So let's do it this way. That's what I'm trying to get you guys to understand. There's always more than one way to do something. And the worst thing that happens to people, I think, in mathematics is early in your math career, you get a teacher who is not flexible. You do something some way, you think you understand it, and they say, no, that's wrong. And you say, screw math. Math is stupid, it sucks. When actually your way is probably just fine. So what's left on that side now? And now you're one step away. How do you get the m by itself? Add 2. All right, there's one possible answer. One method, actually. The other answer is going to be the same. It's just not going to look the same. What's the other main way to do this? I think somebody already told me. Distribute it. Right, that's another main way. And again, they both achieve the same thing. My variable's stuck inside the parentheses. I want to kill the parentheses. I want to free my variable up. One way is to kill the guard. I don't know how you want to get that 3y out of there. And the other way is to bring the 3y in. And then there's no parentheses there anymore either. So if you bring that in, what do you get?
3y in minus 6y.
Minus 6y, I love it. So just multiply the 3y in.
And then add 6y on both sides?
Yeah, now it's a lot like this problem was. Where's my variable? In there, right there it is. So I want to get rid of this guy. Add 6y. And then what can I do there to get m by itself?
Divide by 3y.
Do you see how you almost always divide last, right? So then you divide by 3y. Now, my claim.
I can simplify, right?
You could. You have to be careful about how you do it. These two are the same. They are. Because what's being divided by 3y? This is an acceptable answer, by the way. If you stopped here, you're fine. But I just want to show you that these are the same. What's being divided by 3y here? What and what? A and 6y, right? So isn't this a over 3y plus 6y over 3y? And what's 6y divided by 3y? 2, good. The y's cancel. Don't say 2y. And isn't that the same thing? Right? So they are the same answer. So you got to be careful about sometimes checking your work in the back of the book. Your answer might not look the same, but it's actually the same answer. The book just chose a different way to solve it. Is that cool? Are you guys all right?
Yes.
Did you have a good weekend? Maybe no? Sorry. I was about to say maybe it was a little too good, but some of you guys are like, I did not have a good weekend. Yeah.
I put m equals a plus 2.
Where'd the 3y go?
I'm sorry?
Where'd the 3y go?
Because I thought it would cancel with the 6y divided by 3y is 2.
Great, but what's this?
It's 5?
5, because 10 over 2 is 5. But if I do this, I get 8. Or 1 plus 8, I get the wrong answer.
Okay.
Because what's being divided by 2?
Both numbers?
Both of them. So 2 divided by 2 is 1. 8 divided by 2 is 4, which is the 5 it's supposed to be, of course.
Okay.
As long as you do what the question is asking you to do. It doesn't matter sometimes what order, believe it or not. As long as you do it legally. There are legal ways around order operations. We already know one of them, distribution. Right? You don't have to do what's inside, you can distribute. This is another way to do it. You normally would do the top first, but I could divide each piece. So be very careful about this kind of problem here, and they're saying, bam. That's not right. Okay. So. Do you guys get that? That's going to become very, very important very soon, is to not do that. We're going to be getting these fractions that have variable stuff in them. You don't want to cancel out stuff. So we're in our near future would be stuff like this. And you cannot just cancel 6 and 2, and you can't do that. You can't do that. So division does not cancel addition. I can't just kill one piece of it. But I can pull it apart. That is completely legal.
So, would you want to reduce when it's, like, you said we could stop at 8 plus 6y over 3y.
Yeah, you can stop right here. This is beautiful. I love it.
That's not reduced, though.
It's fine. The difference is actually, to tell you honestly, this next step is sort of making it a mixed number in a way.
Yeah, like, I like to distribute. I don't know, this is what I usually
So you could stop right there, and you're fine.
That's the same answer as the 8 over 3y plus 2?
Yes, it is. Totally.
Is it because the 6 and the 3, like, that's 2, like the answer to 3, 6 divided by 3, 6y divided by 3y
Is 2 plus a plus 3. It's the same thing. And really, I mean, if I have, let's see, like 7 over 2. There's nothing wrong with that, but what have you maybe been taught in the past that you should do next that you don't really have to? What could you do with 7 over 2? Can you reduce it? Make it a mixed number. Right?
So like 3.5.
So, yeah. Would it be 3.5? Which is 3 plus a fraction, a whole number plus a fraction. So this is really just this answer written as a mixed number. How important is it that you exactly understand what I just said? Not very, but what I really need you to understand is this is the same as this. It's just that it's in different forms, right? 3 squared is another form of 9, stuff like that. But this is even different. There's nothing wrong with leaving it here. There's nothing wrong with going further. They're both the same. Just like there's nothing wrong with stopping here. There's nothing wrong with going further. They're both the same. Okay.
I just had a quick side question. If we finish the practice test, can we look at the answer key to see if we got it right?
Oh yeah, I'm going to give you the answer key about halfway through class here.
Okay.
Yeah, don't worry. You'll get that for sure.
Okay.
Yeah.
Can you do one of the word problems?
Oh, sure. Do you have one you're...
C.
Oh yeah. This part I didn't update. I don't know. Did anybody watch tennis or play tennis?
I
Watch. I love me some tennis. I miss me some tennis. I haven't played in a while, but I think this is a year or 2 years ago. Guy Monfils and Rafael Nadal were playing. I think it was last couple years, a year. Yeah, Monfils is crazy. Anyway, you're never sure if he's going to play great or not. But he's makes some crazy good shots. Nadal is just crazy. He's a robot. But how much do you have to know tennis to do this problem? Not at all. How many things are there involved in this problem?
3.
In what way? What are those 3 things?
The total errors, Monfils and Nadal.
So there are 2 things. And together they make something. Do you see the difference? So don't say, I'm not saying you're wrong, just be careful. I only need to list 2 things here to call in the math. All right, so right now I can write the English down. Monfils, Nadal. And this is errors, right? So which one of them is going to be just X?
Gale?
Natal, I like it. It doesn't matter if you know how to say that. That's fine. So natal is X. Why do you know that? How do you know that he's X?
Because there's nothing inside.
Because the other guy is 9 times less.
I like it. So Monfils has made stuff with Nadal. So you got to know Nadal first to be able to do this stuff to it, right? So what do you, of course, these are people, so it sounds kind of weird. What do you do to Nadal to make him Malfi?
3 times
9 less
minus.
than.
Exactly. So it's 9 less than 3 times Nadal's errors, right? That less than is still tripping us up. And that's where you get like negative errors. He was so damn good, he made negative 10 errors. 10 of his shots were like more than perfect. Holy crap. No, it's not.
When it said half, I put 1/2 as a fraction.
Oh, this is 7C. I don't know, let me see.
Oh, oops. Sorry, I was on the wrong one.
Okay, okay. Now, I think somebody said this earlier. What are these two supposed to do? Add to be
87.
to make 87, yeah. So on the homework, I saw exactly the mistake I told you to be careful about. On the homework, I saw this mistake all the time. Because you key in, and there's part of this is okay because you keyed in on 9 less than 3 times. But the problem with this is you're saying that one dude by himself made 87 errors. Now he had a bad enough game as it is, as we'll see. But 87 errors is getting up there. So that's not fair. That's why I pray that you guys will do this for yourself so you don't leave anybody out. That's what this step does for you. So you know you got the one dude and the other dude together did this. So you don't get these funky answers. So now it should be the easy step. Right? Now it's where you just solve this thing. So we get 4x, add a 9.
98. 96.
96, yeah.
24.
And then divide by 4.
So,
Can you do the B?
So what's 24? I'm not done yet, am I?
Oh, sorry.
24 is x, so that's Nadal's errors. How many errors did Monfils make? How do you figure that out?
Plug in the.
63.
Yeah, 3 times 24 minus 9 is 63. I like it. Just to warn you, if you just put 24 and 63, I'm going to be a complete dork. And I'm going to write down bananas, shoes. What do you mean? You got to write the units. And I know that as a student, you're like, oh, God damn it. It just means, do you understand what the hell you just did? Physically, what did you just get? Obviously, it's kind of important, right? So they'll say, okay, Johnson, how much money are we going to lose? It was 3,000 or million? I can't remember. It's a little important to know. Part D. Was that the question, part D?
B.
B. All right, let me shut up for a minute. If you haven't tried 7B out, go ahead and try it out now.
B or D?
7B. B is in boy. This one with the triangle. And we're gonna, anybody else still need a copy of the practice test? You all got it? Okay.
Did you just do that? Yeah.
Where are we at?
3G.
G.
It's a whole bunch of order of
Oh, that doesn't
operations.
look familiar. Let's see. No, not quite.
No?
Oh, you're no, I see what you did.
Okay.
You have the sign there, but you just overwrote it. That's a subtraction, right?
Yeah. So
Minus and negative makes a plus, not times.
Okay.
Cool.
Okay.
So you got second to the last step.
Okay.
You made a mistake, yeah.
Right here, you're supposed to combine my terms on each side, right?
on each side. Yeah.
And then.
And now you start moving things around.
But what if it's.
Don't
but
freak out
but
if the
the end-
variable wants to leave. Let him go.
So
Because remember, if you
4z
get
minus 4z, there's no z anymore.
yeah, there's 0. So if you end up with something like this, for example,
Yeah.
is that ever true?
No.
So what's your answer?
No, not.
No solution.
No solution. Oh.
Because
That's what it is.
so you have a solution, it's got to tell me x is this to make it work, and that's my solution. So this is telling me, well, when -1 is 4, your equation
Are
works.
you gonna have those on the test?
Hell yes.
Oh man.
What does
Okay,
this mean if we get
can you
this?
explain?
This means no solution.
That means all real numbers.
This means all real numbers, because it always
So
works.
nothing on the test is gonna be undefined.
I'm not going to say that.
Oh man, you suck. Okay, what is undefined then?
I like that. Huh?
What is undefined?
What's
then?
undefined?
Anything divided by 0.
Beautiful, right? Division by 0 is undefined, because nothing's defined to multiply by 0 to be some non-zero number.
Okay.
Cool.
Okay, so
Less
here,
sucky.
Let me show you.
real quick, so here when you were saying, if I do the negative to the -9, if I distribute it, it becomes 6 plus 9?
Definitely.
Okay, so
That's, tell me this, because if I have -2 times -3 plus x, what happens here? Positive 6, right? So if I have like a 7 sitting out there, it can't be multiplication all of a sudden, it'll just be plus 6.
okay.
Because minus and negative is plus.
Cool.
What are we gonna make the triangle equal
All the angles in the triangle have to add it to be not 90, on a
So 0 equals 0 is all
you added an extra
Where'd you
angel.
get your C?
All real
1
numbers.
Still all real?
Definitely.
C plus 0.
0 itself is a whole number. It doesn't matter. 11.2 equals 11.2 is all real numbers.
For B,
Square root of 7 equals square root of 7. The thing you're looking at is, if you get a statement that's always true, then it doesn't matter what x is.
No.
It's trying to tell you it's always true.
I did that in my
So when you get x equals 1, it's telling you it's only true when x is 1. If the variable goes away, it doesn't make a depend on the variable. It's either always true or it's always false. There's no solution.
I just, 2 divided by, oh, there's
Sure.
Oh, I just made the bottom mistake.
All right, how's this coming out?
Awesome.
Do you remember what the angles in a triangle have to add up to be? 180. Cool. So 7, B. What are your, what'd you put down here in English? What's the part of the problem? What's the parts? What angles do you have? You have one angle. You have the smallest angle. And you have the largest. Again, there's absolutely no requirement as to what you call these things. I would call them the exact same damn thing the problem does, so that I don't lose where I got it from. One angle, smallest angle, largest angle. They don't have to be 1, 2, 3. They don't have to be A, B, C. That's when you start making it into math, right? So in English, I'm going to write exactly what the problem says. Now, which one is going to be just x? Because the 1 has to do something to the smallest. The largest has to do something to the smallest. So obviously I have to know this guy first. And now what's the 1? He's
3 more than twice.
3 more than twice. So there's twice, and then 3 more than that. Of course, if you write 3 plus 2x, it's the same thing, because I can turn addition around. I just can't turn subtraction around. That's why the less than is the evil one. What about the largest one?
6x minus 3.
I like it. So that's 3 less than 6 times. So 3 less than 6 times. If you turn that around, that's where you start getting negative angles, which I'm not sure what geometry that is. It's freaky-ass geometry. Imaginary, yeah.
And then, sorry, you were saying the inside of the triangle is 180?
Exactly.
Okay.
All angles in any triangle have to equal 180 degrees.
Do we need to know other shapes for the test, like a square?
Not necessarily.
Okay.
But a square would have to equal 360 because it's 4 90-degree angles. Cool.
Okay.
Okay. So what are these supposed to do, like we just said it right now? Together.
Add the 180.
And sometimes I'll say, underline each one so you make sure you have 3. You know there's three things. They all better be in your equations. Oh, you start getting the 11.2 or the negative answers or something weird.
So that's when you combine everything, right?
Yeah, now I just attack it. Now it's on the level of chapter 2. Early chapter 2, section 2.2.2.3. I just get my like terms together. Right? So 2x, x, 6x. 3 minus 3?
Nothing.
None. I'm still seeing a little too much of this kind of thing here. And then I get 6. What's wrong with that?
They're not on opposite sides of the equation.
So you can see why somebody makes that mistake, right? You can see why. They see the minus 3 and they've been told add 3, add 3. No, but I'm all on one side. I only do this to both sides if I wanted to. But these cancel. Why would you do that to yourself? You see that? Cool. If I do plus 3, I've actually just added 6 to him and nothing to him. That's not fair. Right? The balance goes way off to one side. And now the last step here is nice.
Divide by 9.
Good, exactly. X is 20. So up here at 20 what? Degrees. Yeah, and then twice 20 plus 3? 43. And then 6 times 20? 120 minus 3? 117. How do you check your answer? Add them up, and then sure enough, if you add them up, it makes 180. And that feels good, right? When you like, damn, it does what it's supposed to do. Thank God.
Yeah. Could you do 3H for me, please?
Is everybody cool with that one?
Yeah.
Okay.
I did it. I don't.
But do you start to see why this is more than just me saying do it my way? This is a huge recommendation. It helps you set the equation up. It helps you answer the damn thing. I don't know why you wouldn't do this. Everybody who doesn't do this, you're making a mistake somewhere. Right? People that don't do this are the ones that leave something out. Normally it's the poor little X dude, because you say, I got enough X's already. Oh, you're going to get the wrong answer. You leave the poor little one X dude out. Left the whole angle out. That can't possibly equal 180. That can't be true.
Yeah.
3H. Is that what you said?
3H.
3H. Trace Pache. Let's see. Oh, yeah, this is the ugly looking dude.
Oh.
Just to be mean for a second. It's not his fault. Now, there were a few problems like this in the homework, and some people were doing the top and circling that and forgetting the bottom entirely. So you got it's right to one extent. You do the top and the bottom separately, because the very last thing we're going to do here is this division. Cool. So what do you do on the first? What do you do first up on the top?
Get rid of the parentheses.
Do inside the parentheses first, yeah? So what is that inside there?
8 plus 9.
I like it. So 8 plus 1 is 9. Is that cool?
Yeah.
What can you do first on the bottom?
Multiplication. Then
Yeah. You've got to do this as it comes. You definitely subtract last. So don't put negative 17 there.
That one would be. Okay.
Do this as it comes. 21 times 2?
Negative
42.
42. I love it. See, so each one thing you do makes it a much nicer problem to look at. There's a lot less going on there now.
So what did you do? You multiplied 21 by 2?
Yep, right there. So I got to do that as it comes. It's multiplication division, so I have to do it as it comes.
Okay.
Subtraction definitely would come last down there, right?
Yeah.
It's where the end of, please excuse my dumbass son or
I
yeah,
have to
son.
remember all the time. So yeah.
So what do I do now on the top?
The exponent.
Exponent. I love it. What's 3 cubed?
27.
27. Very cool beans. On the bottom,
Divided by 7.
42 divided by 7, 6.
Okay. Wait. Okay.
So let me stop right there and let you guys absorb.
So 6 over. subtracted first,
So you divide 27 by 9.
Yeah, so now the next thing I do, I'm sorry? Whoa, alright. So let's see what happens. What do I, on the top?
Okay.
2 plus 3.
Yeah, 27 divided by 9? 3? Be careful.
So 6 divided by -2.
Yeah, 2 plus 3 plus 1 is 6. 4 minus 6 is -2.
And equals -3.
-3, yeah, cool. So really, most of you guys kind of know order operations, but you try to do too much, or you forget a symbol, which totally throws everything off. Or you make a mistake like the most common mistake I see is this one. That type of thing. You know that minus and negative makes plus, but it doesn't make multiplication out of it, right? It should make plus. Subtraction cannot become multiplication, but it can become addition. Hell yeah. Subtracting a negative is adding, right? Forgiving debt is adding money that you can use, right? That's what I think of as subtracting a negative is forgiving debt. I think of it like that. You're adding money into my bank account, hopefully. Does that make sense? You guys have really good poker faces. Yeah.
For F, I just have a question. For 3F, I'm sorry. For 3F, you know how it says 5 minus 8 in those straight lines?
Oh yeah.
And then the negative is outside, does that turn into a -3?
So, I don't think I talked directly about absolute value. So that was one thing I left for you guys to kind of review in the chapter 1. But a real quick thing about absolute values. What would that be? And what would this be? Because it always comes out, or 0 at least, right? Because the absolute value, why does it always come out positive? What's it based on? It's based on distance. How far away is -7 from 0? How many steps? 7 steps, not -7. You wouldn't say, how far away from school do you live? -20 miles. Are you down? What does that mean? In a black hole, another dimension? I don't know what that means, right? So absolute value is based on distance. So if the absolute value of -7 is 7, what's this thing? I like it, because what's that? That's 7. And then you put a negative on it. Cool. Because the absolute value can only take care of what's inside of it. You can't do a damn thing to that poor little that negative out there is like, aha. You did all the work to make it positive, but I'm still negative.
So whatever's inside the absolute value, it's gonna stay positive.
That number needs to become or stay positive.
Whatever the answer.
Yes, the output. So absolute value -7 must be positive 7.
So after you do the whole solution from left to right, whatever the answer is gonna be negative?
No.
You don't worry, you just
So you gotta be careful. This one little piece of it. This is 3F. So this can't control what's going to happen with the whole thing. So I don't know, maybe the whole thing will come out negative. In fact, it will, just because they're both negative pieces. But this only concerns with this. Yes, ma'am.
right.
Is the absolute value considered like grouping symbol?
Yes, good. It's on the same level of order operations as parentheses. You read my mind, which is scary. I was about to say that's where it comes. And PEMDAS, this is where absolute value comes. They're like parenthesis symbols. You do inside there first, and then you force that number to be positive. Be really careful though. What did I do wrong? Did I do anything wrong there?
You did subtract
The
one more.
big thing wrong. I'm taking the absolute value of some number. If I don't know what number's in there, how can I take its absolute value? I can't turn a piece of a number positive. I have to turn the whole number positive. So what is 5 minus 8? And that's what I turn positive. Now, of course, poor little dude, once he does its job, absolute value -3 is 3.
But it's still negative.
And there's a minus sign on it, so it becomes minus 3. These two negatives cannot cancel, right? That negative can't come inside. You've got to do the absolute value first. Yes, ma'am.
Oh no,
It's another question.
Okay. And then we get the rest of this here. How we doing? We okay?
Then you multiply the left.
Zach, now you multiply. Negative 3 times 6.
Negative 18.
Negative 18. Divided by 9.
But then it's divided by.
Negative 2 minus 1.
Oh, so you don't subtract the 1 from the 9.
Right here, what do you definitely do last? Subtract. You have to do this part as it comes. So this one, it turns out, to do it correctly, you do everything straight up this way. It's just coincidental.
Why is negative 3 positive?
So is the answer negative
At the very
3?
end?
Yeah, it's negative 3.
Alright,
But you have two negatives, so why don't we have a positive?
Oh, this if I owe you $2 and owe him $1, I owe $3. It's still negative. When do two negatives make a positive when you do what operation? Multiply. Cool. If this is negative and it's getting even more negative, it's even more negative, right? Think of subtracting as going down on the number line. You're getting even more negative. Cool.
Can you do the next one, G?
Oh, yeah, well, real quick.
I'm sorry.
I was gonna say, actually, J.
J.
Through J.
Okay. So, should I end up with an answer here? Is this in an equation? No. So I'm just going to have to be at like terms together. I can't go any further than that. Plus, there's like at least two variables. There's x squared and an x, and there's a y squared and a y. Well, this is just a y. So what can I do first here to try to simplify?
Distribute.
Beautiful. Just drew that 2 through to free those up. Because I really want to get to the point where I just put my like terms together, but I can't do that unless they're free to move around.
Do you apply the 2 to the exponent? Or is the exponent stay the same? Because I wrote 2y plus 9x squared.
So there's a couple things going on there. Twice 3 is not 9, so I think you're thinking too much about the square.
Never mind, maybe I just didn't care.
Okay. So I think your question was really, does that square go to the 3?
Yeah.
And I had some people confusing that issue because x squared means square the number I don't know yet. And if I have 3 of those, does that suddenly become 9? I've only got 3 of them, right? What's being squared here?
I guess, yeah.
Don't guess. What is the square sitting on?
I would have done 3 times, or 3 times 3 is 9.
What you're thinking about is this.
Oh.
See how the square is on the 3?
Oh, but it's to the x.
Exactly. And can I do anything with that? No, I don't know what x is, so I can't square it.
Okay.
So sometimes we feel like I'm not doing enough. Like there must be something I can do with this. No. This doesn't become 9x. That square can't jump over and go to the other dude, right?
Okay.
Cool. So here I get twice y.
Minus 6.
Good. Minus 6x squared, because twice 3. 6 and it's a minus. And then plus 3x.
That's a minus y, not plus y.
Oh, thank you. And what are my like terms here? Is there anybody that goes with him? Yeah, so the y's can go together. Who goes with this guy?
The negative
You know, the x squares. And who goes with him?
myself.
No. Forever alone. So 2y minus y. Y. Negative 6x squares minus 4x squares.
And x squared.
X squared.
Good. Don't put 4 down there. I'm like, I don't see any x4s up there. How can you suddenly have 10 of them? I've got 6 of these, 4 of these, I got 10 of these. Minus. And then at the end I just put my poor little plus 3x. I don't care too much at the moment about descending order, putting it doesn't matter. You can leave it like that. Get your like terms together, we're good.
you don't want us to do the square root? I mean, not the schematic. It says negative 10x squared. You don't want us to like 100x?
So again, we had that discussion a second ago. This is not this. The square here, I'm squaring a number I don't know yet, right? So it's not that. So if I had 10 times 2 squared, what's that? 40. You can't choose to make it 200. You can't square the 10 instead. That's not allowed. So if I put an x there, it's got to act the same way. Because x is just a number I don't know yet. I can't choose to square the 10. The square is on that x. Cool.
You have to know y or x to solve it.
Exactly. Until they give me a y or an x, I can't do anything else. I don't know what those represent, so that's as far as I can go.
And then a question. The way I put it, maybe I confused, but I had negative 10 x squared plus 3x plus y.
That's perfect.
Okay, good.
Yeah.
Either way.
The order doesn't matter yet. Yeah. Yeah.
I had a question from the homework.
Okay.
There's a lot of questions.
All right.
It's on page 104.
Number?
Well, you pick whatever one you want. Maybe 70.
Oh, so yeah, give me an area that, a type of problem. So 70?
Yeah.
Okay. Some of these, I agree, are kind of weird. 70 happens to not be too weird, but some of these other ones are kind of weird. A football player gained Y yards on a punt return. On the next return, he gained 6 yards.
On what page?
This is page 106. So if he gains Y yards on a punt return, and the next one he gains 6, how much does he gain total? Yeah. Now let me see where they get freaky. Oh, like number 72. Look at 72. A hockey player scored 42 goals in one season. He scored N goals in one game. How many goals did he score in the rest of the games? This is where it gets weird. So he has a total of 42. Stay with me now.
Oh, no, sorry.
And in one game he scored N goals. Now here's where you can give yourself a little leeway. What are you allowed to let N equal? Anything. In this case, up to 42, because you can't score more than 42 in one game. So what if N was 10? Like he had a crazy, awesome game. He scored 10 goals in one game. How many goals did he make the rest of the season? Think about it. Don't think about algebra. If he's got 42 total, he scored 10 in one game. The rest of the season he scored 32. How'd you get that? Beautiful. Where did I get the 10 from? Exactly, from out of the air. So if I have a total of 42, what did I do with the 10 that I'm going to instead do with the N? Exactly. Because if he would have scored 2 goals in one game, how many did he score in the rest? 42 minus 2, 40. So there's a little hint as to what to do with how to change it from English to math. You can pick what number to put in. See what your brain does and do the same thing with the letter. Because our brain likes numbers. It jumps on numbers. So if I score 6 goals in one game, that means I must have made the other 36. 42 minus 6. And that's it. They just want an expression. That's all they want. There's nothing to solve. They just want an expression. Yeah. Yes, sir.
Could you do page 125, number 24? Actually, 135. I mean, it's 2.5, number, yeah, page 126, actually.
Number 25?
No, 24.
24, okay.
Yeah.
This is page 126, number 24. And this one, they got a funky A. That's an A. It's 1/2.
4 plus 4. All of them is plus 4. That's it? Okay. There's my issue.
And they tell you several things. This one's nice. This is not the section where you have to solve purely with letters. Because they actually tell you, they say, oh yeah, A is 75. What else do they say? Little b is 19. And big B is 35? 31. Cool. And they want to solve, what letter do you think they want you to solve for?
So that equals -1.
What's the only, yeah, H is the only one I don't know. Cool. So this is kind of nice. You plug everything you know in. So this is not quite the evil part yet. So of course, where's 75 go? A, cool. So 75 equals 1/2 H times little b plus big B. See, now you can attack that directly. You only have one letter in the whole thing. So now you can put your like terms together, right? The nice thing is here, I would do half of this, kill that fraction right away, and then you just got one step away from having H by itself. So that whole section, they give you values to plug in.
And just add it.
Yeah, so now, yeah, you add these together. And then half of 50, 25. And then to solve for H, you just do what? Divide by 25, yeah. Cool.
Can you try number 48 on page 128?
So H is 3 there. 28?
48.
48 on
128.
128.
Yes, please.
Okay.
Thank you.
So this one, the Rogers Center in Toronto, Canada, has a hard shell retractable roof. The steel dome is 630 feet in diameter. What's the circumference of this dome? Okay. So basically looking at it from overhead, 630 feet in diameter. Who remembers the formula that I need is asking me for the circumference?
C equals 2 pi r.
I like it. So one option is 2 pi r. What was the r? What that represent in radius? What is twice the radius? Diameter. So another formula for this would be 2r is d. And now, of course, it's going to, no, it doesn't matter. You can actually, if you cut this in half, you'll have to double it again for the formula. You'll end up in the same place. But the more direct way to go, that's the diameter they gave me. I just got to throw it in now. You should have a calculator that has a square root button, and most of the time if it has that, it's also got a pi. If you're unsure where your pi is, or that one probably doesn't. But like graphic calculators obviously do, scientific calculators definitely would. If you don't have one with a pi button, just use, what's your best approximation for pi? 3.14, cool. Just use that.
Is pi an integer?
No. It's at least decimal, which would make it rational, but it doesn't stop there, right?
Okay.
Wait, rational or irrational?
It's totally irrational. Yeah. As far as we know. There are people that are going on with this thing hoping it's going to start repeating itself. They're crazy. One of my students in my calculus class knows this out to like 20 places. That's as far as I know, and that's as far as I care to know. Thank you. How much space left in my brain. So to do this problem, and just to let you know, they don't let you totally hang by yourself. I mean, they give you these formulas here. Oh, actually, yeah, in the very back, you got perimeter formulas, you got area, volume formulas, circumference is in there. Okay, so if you forget any of these formulas and they come up, they should either have an example like that, or they'll have it in the back of the book, right, very back. So now how do I get the circumference? What do I put in? Where?
Pi times 630.
Yeah, circumference is pi times the diameter, and they told me the diameter is 630 feet. So now either use your pi button or do 630 times 3.14, approximate what the answer is going to be.
1979.
Right, it's a good year. And put what on the end?
Square?
Feet. Not square feet, right? Circumference. It's not, it's just a measurement around. It's not a measurement covering something. That would be square feet, right? Covering is area. Filling is volume. Measuring straight like that is just linear. It's just feet. Cool.
What section? I'm sorry.
2.5.
But is that the formula that you're supposed to use?
Yeah, definitely.
Wait, so
What's the
This
difference?
one or this one.
Oh, is it another either?
Because what is twice the radius? The diameter. So these are really the same formula. See that? 2r is d. These are the same. Because real quick, how would you get the radius here? And then what would you do when you plug it in the formula? You would double it. So you'd be in the same place again. So it's the same formula. Just depends on if do you know the radius or do you know the diameter. Yeah. Yeah.
Okay. On 4f, for whatever reason, distributing to a negative integer is frustrating.
Oh, I see what you mean. Here's a suggestion. Oh. Trying to stay in front of my camera. Here's a big suggestion. If you have any trouble, this is on the practice test 4F. Of course, I was nice and evil and I did two of them in one.
Yes.
Anytime. Here's a suggestion for how do you rewrite 2 minus 3 times something? How can you rewrite that as plus a negative? Then you won't forget that the negative's got to go through with you, right? That is the biggest mistake I see is people will take this and on the next step I see this. What mistake did I make?
is it plus 3c?
Yeah, negative times negative is positive, right? And this frustrates people because they're like, well, I'm not taking the negative in, I'm taking the 3 in. Well, okay, if you're taking the 3 in, let me just look at this one piece. Is that cool? Just as one piece? If you take the 3 in, you should write it like this. You haven't taken the negative in yet.
Okay, and so for the other side, it ends up being negative 4z. When you do the negative 4.
Negative 4 times negative z is positive 4z. Cool. So you get 2 minus 6 plus 3z, plus z, equals 5 minus 4 plus 4z. I love it. And now you put your like terms together. This is one that comes out to be one of the weird situations. Your variable goes away. On the homework, I'm getting a lot of people subtracting 4z from 4z and it equals z. Don't force the variable to be there. Let him go away if he wants to, right? So here that's going to happen, isn't it? I get 2 minus 6 plus, well, what's 2 minus 6? Negative 4 plus 4z equals 1 plus 4z. If I try to get my z's together, minus 4z both sides, they cancel. So I get negative 4 equals 1. No solution. Good. Because again, what does this mean? When I solve an equation and I get to the end, if I get x equals 3, it means the equation is true when x equals 3 is true. So I get a specific answer. When is this true? The equation is true when this is true. This is never true, therefore, does anything make this equation true? No. No solution. Yeah?
Can I ever put false instead of no solution?
No. Because I really want you to understand, it's not just me being picky. Your answer has got to be the solution. So if there is no solution, you have to say no solution. Just saying that this is false doesn't tell me what the answer is. Do you see the distinction there? So I need to see the answer. So if there is no answer, say no solution, no answer. Don't just circle this, because that's kind of a major finding, right? If that were true, it's not. And don't say false, say no solution. Yes, sir.
Can you do number 45 on page 105?
Page 105, number 45. Oh, yeah. So, on this problem, you have the option if you want to use it. Since it's an equation, what could you do with those fractions if you wanted to? Do you want those fractions to be there? No. So you can get rid of them because it's an equation that has two sides. Right? Because killing fractions is easy if I'm allowed to do it. If I have this problem, I am not allowed to kill my fractions. I have to deal with them. Right? But with this problem, I have an equation. I can do the thing that would kill the fraction if you want to. You could instead just go ahead and distribute this. And see how it's not that evil? Doesn't 4 go into 12? So it's not as evil as it could be. They could have put a 5 there, and it would have still been an ugly fraction, right? So let me see. Let's try it both ways. If I distribute this in, what do I get?
Negative 1/4 x.
Beautiful. Plus, good. 12 divided by 4 is 3. How we doing? All right, 1/4 of x is there. Negative 1/4 of 12 is there.
You cancel the 4 out?
Yeah, so what I'm really doing here is negative 1/4 times x plus, right, negative 1/4 times 12. And then the 4, of course, cancels, goes into the 12. Sweet. And then the same thing here, right? What do I get there?
1/2 x.
1/2 x.
Plus 1.
Half of 2 is 1. I like it. Equals x plus 4. Now you get your like terms together. Yes, ma'am?
Oh, sorry. I keep interrupting you. It's quite
You do. Okay, so this piece is nice. This is plus 3.
And
Where are my like terms? Write it out again. So here's like terms there. These are like terms to the point that they're both x's, but they're not like yet because they don't have same denominator. That's not too bad, right? 1/2 is also known as 2/4 to make it the same denominator. What's 2/4 minus 1/4? So that's all I'm doing there is rewriting that as something fourths. So now negative 1/4 plus 2/4 is positive 1/4, right? Negative 1 plus 2 is 1. So putting these together, 3 plus 1. Oh yeah, I remember this problem now. A lot of you guys got almost done with this problem and then you got freaked out by the last step. How are we doing so far though?
How'd you get 2/4?
1/2. And why do I need to change 1/2? Because it doesn't have the same denominator, right? So I multiply the top by 2 and the bottom by 2 to make it 2/4. Right, because 2/4 is the same thing as 1/2. Cool. How are we doing so far? The look on some of your faces, I tell you. Yes?
Are we done with that one?
No. Have I gotten to an x equals part?
I'm not paying attention to that one. That's it.
All right. So what's the next step here? Minus 4. And this is where people freaked out. Most of you guys just stopped here. I really almost can't blame you too much. But there's two levels of ugliness on this. There's still a fraction in there, and there's x's on both sides. But we know if I had this, what would you do next?
Subtract 1.
Yeah, minus the 1/4 over to get the x's together, right? Because the numbers are already all right there when I subtract 1/4 over.
Could we multiply the 4 away?
Yeah, you could do that too. You could you could have killed it up here, but you can kill it right there. What I'm trying to get you to understand is, even if, because we'll get to something like this here, 2x equals 3x. That looks like it should be easier than this, but people still get trouble with this. But if I just put a +2 there, people are like, oh, you subtract the 3x. But just because there's no +2 there, there's a +0 there, I don't not do the same. I do exactly the same thing. I could subtract 2x here, get my x's together. And then x is 0. I'm done. Same thing here. I subtract my 1/4. So you get my x's all on one side. So I'm desperately trying to get you guys, the equation does not dominate. We're humans. We tell the math what the hell to do. Here, my x's are not together. I don't care that there's not another number up there. My x's have to be together. So I pull one to the other side, subtract one of them over. What is a whole x minus 1/4 of an x? Yeah, 3/4.
Why? Why?
Why? Right here, I got 1x minus 1/4.
Oh, yeah.
So to make it over 4, I make it 4 over 4. So that's the 4/4 minus 1/4 is 3/4. Cool. Yeah. And then what's the last step there? How do I kill a fractional coefficient? Who remembers how to do that?
4 over 3.
Beautiful. Multiply both sides by the reciprocal, that'll kill it. 4/3 times 0 is 0. So x is 0. Sometimes I'll get somebody to get x equals 0 as an answer, but then you'll say no solution. 0 is a number. It is a solution sometimes. Right? So don't think that that means something. X is 0. That's all it means. If x is 0, this is a true equation. That's what that means. Yeah. 4C? What's up? Sorry.
Just before we start from that one, if it's okay, can you just show us how to eliminate the fraction?
Oh, sure. Let me put it here. So don't forget, you wanted 4C, right?
Yes.
Okay.
Which one is this one?
This is from the book. I think I had it up here.
105.
Yeah, page 105, 45. All right. If I want to kill the fraction at the beginning, which I understand, actually, if I can do it, that's awesome. I don't really want to work with fractions if I don't have to. You should be able to, but why do it if I don't have to? So how do I kill these fractions?
Find a common denominator, then multiply by the reciprocal of that.
No, you gotta be careful. How would you kill 1/2? What would you multiply by?
2 over 1.
2, right? And be careful, if it was a 3 over 2, I wouldn't multiply by 2/3 because then I'm just putting another number on the bottom. What I really want to do is I want to kill the denominators because that's what makes a true fraction, right? 3 is fine. 3 over 2, not as nice. So if I just multiply by 2, I'd kill it. But would that kill this?
No.
So you always do the LCD, like you said. The LCD will have both of these in it. So they'll both go away. And of course the LCD is 4. So if I multiply everything by 4, right? I'm allowed to do that because I have two sides of the equation. How are we doing so far? What's 4 times negative 1/4? The 4 is? I like it. So I get negative 1 in front of this. How are we doing? Sure.
You do that to both sides.
So what I really want you to understand is when we learn rules like this, they can never change. Nothing we learn can ever change. We just learn more. So, whatever I do to one side after the other is true